Good morning, students. Today we will discuss about limitations of Bohr's atomic model. We already discussed about Bohr's atomic model postulates. After that, this topic is next topic. So, what are the demerits? What are the limitations of Bohr's atomic model? So, limitations of Bohr's atomic model. Limitations of Bohr's atomic model. So, what are the limitations of Bohr's atomic model? Demerits. So, first demerit is actually this atomic model is only for single electron atom only. Single electron atom. So, single electron atom like hydrogen or hydrogen like ions. This is first demerit. What is hydrogen? What is hydrogen like ions? For example, this is the nucleus of hydrogen. It has only one electron here. Hydrogen has only one electron. We will take helium. So here, how many electrons? Helium, 2 electrons. Here 1 electron, here 1 electron. Lithium, 1s2, 2s1 atomic number. Therefore, here 2 electrons, here 1 electron. Lithium, 3 electrons. So next, He plus 1 means helium lost 1 electron. Therefore, it has only 1 electron. Next, Li plus 2. So here 1 electron. So no 2 electrons, it lost 2 electrons. Therefore, here hydrogen, this Bohr's atomic model is applicable for this hydrogen. It is not applicable for helium. It is not applicable for lithium because here 3 electrons are there. But it is applicable for helium plus 1 because after losing 1 electron it has only 1 electron. Therefore, it is applicable for He plus also, and it is applicable for Li plus 2 because it already lose 2 electrons. Therefore, it has only 1 electron. Therefore, hydrogen and hydrogen-like species only it is applicable. This is first postulate. After that, this first limitation. This first limitation. Second limitation is it is not applicable for multi-electron atoms. Multi-electron atoms such as sodium. Sodium atomic number is 11. Or sodium ion plus 1. It has 10 electrons. It has 11 electrons. So it is not applicable for multi-electron atoms like sodium ion. For example, if it has plus 10 charge, means how many electrons are there? 1 electron. Therefore, it is applicable for sodium plus 10 ion. But it is not applicable for these 2 ions, this sodium atom and this sodium ion. If it is loses 10 electron, it has only 1 electron. In that case, it is applicable. After that, third limitation is so it is explained about the spectrum of single electron. Spectrum of single electron single electron, and it failed to explain the spectrum of multi electrons. So what is spectrum? So light passes through this is radiation or light. It is radiation or light passes through the prism. This light is diffracted like this. So when you observe a screen here, you arrange a screen here, you observe these single individual lines. The combination of these lines is called spectrum. So it explains about the spectrum of single electron only. So single electron like hydrogen spectrum only explained by this theory. It is failed to explain the spectrum of sodium and remaining elements. So here for this it is failed to explain the fine spectrum of hydrogen. It failed to explain the fine spectrum of hydrogen. It is failed to explain the fine spectrum of hydrogen. What is fine spectrum? So here this is single line. After it is combined with another line like this. This is doublet is also called as. After this line has small lines are there. This is called fine spectrum. It is failed to explain about the fine spectrum of hydrogen. It is other limitation or demerit of Bohr's atomic model. After that, next one is, fifth one is, it failed to explain the Zeeman effect. What is Zeeman effect? It is failed to explain the Zeeman effect. So actually it is spectral line. If you are arranging the magnetic field, North Pole here, this is South Pole. So this is total, it is known as magnetic field. So splitting this spectral line is split into like this. This is spectral line, and in presence of spectral line, splitting of spectral lines in presence of magnetic field. Splitting of spectral lines. In presence of magnetic field. Is called Zeeman effect. So why this spectral line? One single spectral line is split into smaller like this. Smaller. This is also called as fine spectrum. So here, splitting of spectral lines takes place in magnetic field. That is called as Zeeman effect. This theory is failed to explain about the Zeeman effect. Why Zeeman effect is caused? What is the reason for that? It is failed. After that, it is also failed to explain the Stark effect. It is also failed to explain the Stark effect. What is Stark effect? So here, this is spectral line. Actually, it is a spectral line. So same spectral line is right in place of electrical field. This is electrical field. Splitting of spectral lines in place of electrical field. Splitting of spectral lines in electrical field is called Stark effect. This is Stark effect. This is Zeeman effect. It is electrical field. One is positive, other one is negative. This line is also split like this. split like this. So this is spectral line. One spectral line is split into so many spectral lines. In presence of it is happening in presence of electrical field, that is called as Stark effect. If it is happening in presence of magnetic field, that is called as Zeeman effect. Splitting of spectral lines in magnetic field is called Zeeman effect. Splitting of spectral lines in presence of electrical field is called as Stark effect. So Bohr's atomic model is very explained about Zeeman effect and Stark effect. After that, this theory, Bohr is not an agreement with Heisenberg's uncertainty principle. There is no agreement between, so there is no agreement. Bohr is not an agreement, with Heisenberg's uncertainty principle. This is 7th point. Heisenberg's uncertainty principle. Heisenberg uncertainty principle. So Bohr is not an agreement. So after that, Heisenberg is proposed a rule or principle. There is no relation between Heisenberg principle and Bohr's theory. And eighth one, there is no an agreement with de Broglie's theory. De Broglie's theory. According to de Broglie, electron is a particle, has both nature, particle nature and wave nature. So electron move from one place to other place as a particle nature and also wave nature like this. This is wave nature. But according to Bohr's theory, it is considered as a particle. Electrons are revolves around the nucleus, means that is considered as a particle. So according to de Broglie theory, dual nature is there for electron. Dual nature, both nature, particle nature and wave nature. Why it has both nature? Both theories failed to explain about the dual nature of electron. Means there is no agreement with the de Broglie's theory also, and it is also no agreement with the Heisenberg's uncertainty principle. That is also no agreement with that one also. After that, next is orbitals. So orbitals are three-dimensional arranged in the space. So they are arranged in three-dimensional manner in space. For example, if you take p orbital, three lobes are arranged in three different spaces like this. This is three-dimensional manner. So this theory is failed about the 3D manner of orbitals. 3D manner of orbitals. Why they are arranged in the space in three-dimensional. So this is also one of the important demerit of Bohr's theory. After last one is according to chemical bonding molecule. For example, water molecule V shape or bend shape, ammonia molecule a pyramidal shape like that. So this failed to explain about the geometry and shapes of the molecule. Geometry or shapes of the molecule. It is also one of the demerit of Bohr's theory. So first demerit is it is applicable for single electron only, like hydrogen atom or hydrogen like ions. And also it is not applicable for multi-electron atoms like sodium, potassium, like that. It is only applicable for single electron only. And third one, it explained about the spectrum of single electron only, and it is failed to explain about the spectrum of multi-electrons. That is fourth. Multi-electron means that is fourth point. After that, it is failed to explain about the Zeeman effect and Stark effect. Zeeman effect means splitting of spectral lines in presence of magnetic field is called as Zeeman effect. Splitting of spectral lines in presence of electrical field is called as Stark effect. It is also one of the demerit. After that, there is no agreement between Heisenberg's uncertainty principle and de Bohr's atomic model. And there is no agreement in between de Broglie's theory and Bohr's atomic model. And also it is failed to explain about the three-dimensional manner of the orbitals. Why orbitals are arranged in space in three-dimensional manner. And also according to chemical bonds theories, it is failed because molecules are having shape and geometry. Why they are having shape and why they are having geometry? It is also one of the demerit of Bohr's atomic model, and these are the limitations of 10 limitations are there. It is also very important. It is about Bohr's atomic model.